Hello, everyone. Welcome to our last session this afternoon before we break and do keynotes this evening to kind of kick off the conference. I'd like to introduce you to Fabian from Keyless, and he is going to talk a little bit about how you can combine Passkeys with strong identity. So take it away.
Thank you very much, and hello, everyone. It's a pleasure to being here. My name is Fabian Eberle. I'm COO and co-founder of Keyless, the leading provider of privacy-preserving biometric authentication. And today, I'd like to talk to you about biometrics, what it is and how it works, introduce some of the existing systems, but also a new paradigm that we call decentralized, zero-knowledge biometric authentication. And I want to share some examples of how this is used today to complement passkeys, especially to secure high-risk actions and enable self-service account recovery. But before we begin, I'd like to highlight the challenges we all face with authentication today. Account takeover fraud is at staggering levels, despite all the technologies that are available. Oops. Apologies, I think the slides won't show. So account takeover fraud is at staggering levels, and it's a big challenge for many of us, despite the technologies that are available. And at the core of the problem are passwords, and that's what we are here for today. And while passkeys are putting us on a path to eliminating the password, account recovery remains a major challenge. And we believe biometric authentication is key to addressing these remaining challenges. When we think about regulated industries, such as banking, biometric authentication is already seen as the most effective capability to addressing these security and fraud challenges that still exist. So let's define what biometric authentication really is. Biometric authentication leverages unique or distinctive physical or behavioral human traits to identify identity. Distinctive means they are unique, and the more distinctive, the better the biometric. Physical biometrics can be face, fingerprint, or iris, whereas behavioral traits are the way we use our phones, the way we swipe, the way we type, so keystroke dynamics, which are unique to an individual and to any of us. Now, this market is gaining rapid traction. It's growing at about 20% year on year. It's even faster than the overall customer authentication market that's growing at around 17%. So according to Liminal, identity strategy firm, that'll grow from 18 billion this year to 39 billion in 2028. And that's no surprise, because biometric authentication offers several unique advantages. First, they're very easy to use. They don't require training. Each and every one of us is using a face biometric every day when we unlock our device. They're hard to phish, and they're strongly tied to a specific individual. They typically cannot be shared if liveness is implemented correctly, and they're overall at a lower operating cost than security tokens. Now, in order to use a biometric system, we need to register or enroll a user first to be able to authenticate. In that enrollment process, the user is taking an enrollment selfie, and we're talking about facial recognition. The biometric features are extracted, and they're transformed into a biometric template that is securely stored. Now, in an authentication, the authentication selfie is captured, so the user looks into the camera. Biometric features are extracted. The biometric template is loaded, and those two items are then compared with each other. And if that biometric match is successful, so is the authentication. Now, these systems can run on the device locally, meaning both enrollment and face matching is happening locally on the device. No biometric data leaves the device, which is a local or a device-native biometric, leveraging the platform authenticators. On the other hand, that process can happen on the server side, away from the device, a centralized or server-side biometric. Now, when we look at local biometrics, the major strength of that modality is that the biometric data never leaves the device. We want to avoid that central honeypot of very sensitive personal information. But that comes at an expense. When we use multiple devices, we have to register and enroll our face on each and every device that we want to use. That means it provides a weak link between the actual user the person behind the device and the biometric that sits and is stored on the device itself. So it doesn't really count as an inherence factor when we're authenticating to a remote server. When the device is lost or stolen, so is our biometric data. So account recovery is a challenging process that modality does not support. On the other hand, the centralized biometric, where that both template creation, so enrollment and face matching is happening on the server, the biometric templates can be used across multiple devices. We can look into any device and authenticate against the template that is stored in the cloud. We don't need to re-enroll on each and every device that we want to use. It supports account recovery flows, and it provides a stronger link between the biometric that is stored and the genuine identity of the person actually authenticating. However, this system comes at major expense. The cloud or the server where that all the data is stored has obviously access to the biometric information. So we're creating a centralized honeypot of sensitive personal information. There's risk around data breaches and data exfiltration. And many of the data protection or data privacy regulators are pushing against that framework when it comes to ongoing authentication, which is distinctly different to the initial remote onboarding or IDV, identity verification, when we are creating an account digitally. But what if there's a way to assuring our identity in a way that assures identity but doesn't come with the disadvantages of storing biometrics server-side? We call this paradigm zero-knowledge biometric authentication, a decentralized approach to biometrics that leverages privacy-enhancing technologies. Last year, Gartner introduced a new category they call decentralized biometrics. They define it as a category that leverages cryptography or privacy-enhancing technologies to basically avoid that no single entity has full control over the biometric data. And they argue that that category offers a greater balance of usability, user experience, and privacy. Our approach to decentralized biometrics is called zero-knowledge biometric authentication. And it isn't just a system where no single entity has full control over the biometric data. It's a system where no biometric data is stored at all. With keyless, a user's face is transformed into a cryptographic key that can be used for a one-time action, such as signing a document, authorizing a payment, or recovering a user's account, after which that secret disappears. But there is no biometric data, so no template stored on the user's device, but neither is any of that sensitive information stored on the server side either. And of course, we're also having an enrollment or a registration process to then further authenticate the person against that template. That enrollment process involves two things. First, the user's device is bound to their account, and we're generating a cryptographic device key pair on the user's device that binds the device to the account and that is then cryptographically verified in each and every subsequent authentication. Distinct from that, we are registering the user's face. So the user looks into the camera, we're extracting the biometric features, we're performing a passive liveness check, and then we are transforming the user's face into what we call zero-knowledge biometric data. So it's a one-way cryptographic transformation that is decrypted with a key that exists on the user's device and is then stored on the server side where no decryption key exists. So when the user authenticates, we're capturing the user's face, we're transforming that information in that zero-knowledge biometric data, and we're then matching these opaque cryptographic strings of information in the encrypted domain using a multi-party computation scheme to authenticate the individual. And if the user is using any of their trusted devices and presenting a fresh face of themselves at that very moment into the camera, the authentication is successful. A private key or a cryptographic key is reconstructed on the user's device, is used once, and then disappears. Now, this new paradigm has several benefits. First, it provides genuine identity assurance, so it truly authenticates the person behind the device. In addition to that, we're also cryptographically verifying the device itself, so we provide built-in multi-factor security. It also protects the user's privacy. It even goes further than that, because there is no biometric data that we store. And this is confirmed by data regulators across Europe, the UK, and other regions where this technology is commercially deployed with tier 1 financial institutions. It also provides a slick and smooth user experience. It looks and feels like Face ID. It takes 300 milliseconds to perform, and the user is authenticated in a consistent experience that is agnostic to the device, with the only hardware requirement being a camera of 720 pixel or higher. And lastly, it isn't just a user experience uplift or provides better security, but it really provides tangible business outcomes in the form of operational efficiency by reducing call center volumes, by allowing for high-risk actions or higher approval rates in high-risk actions when we think about high-value payments as an example, and obviously reduced fraud from an account takeover perspective. Now, this capability can be used across the entire identity lifecycle of the user. It starts from the initial enrollment and registration, where we register the user, to then further authenticate the user across the value chain from login events over step-up actions such as high-value payments, changing of sensitive personal information like address data, strong customer authentication in the context of open banking and PSD2 in Europe, which mandates multi-factor authentication for each and every transaction above 30 euros, and dynamic linking, essentially linking the payload to the payee and the recipient of that transaction and make it auditable for the bank. New device bindings, adding devices to user accounts, and obviously the account recovery. Now, I'd like to touch upon 3 of these user journeys. The initial enrollment, which obviously can happen on the device, just like we add our face to our phones, but it can also happen in a very elegant way, completely transparently in the background that I want to touch upon. I'd like to share an example of a step-up action to protect a high-value transfer, in this case, strong customer authentication under PSD2. And I'd like to share a PIN recovery or an account recovery of a bank in Europe that has implemented this flow. Now, what you see today with especially regulated entities that are mandated to perform an identity verification to onboard a user, where the document is verified, the selfie is captured and compared against that government-issued ID. This initial identity verification as part of a KYC process is completely separate to how we authenticate that onboarded user going forwards. We're issuing the user's account, they have username and password, or they contract a policy number. They link their mobile phone in that onboarding process to the account, so they receive SMS OTP codes as a modality for two-factor authentication. And that obviously brings a lot of friction, a lot of complexity, and doesn't solve the account takeover fraud challenge that we have today. What we introduced with Keyless is a service that we call Identity Verification Bridge, or IDV Bridge, that connects and bridges identity verification with ongoing authentication without asking the user to re-enroll and take another selfie to then biometrically authenticating themselves and assure their genuine identity. So what we're able to do is leverage the selfie information that is used in a digital onboarding process and feed that information into that IDV, or Identity Verification Bridge, a container that runs on the customer's premises or with our IDV partner, and that then transform that selfie into that zero-knowledge biometric data and generates the device key pair in the background so that the user activates Keyless with the first authentication the user makes, which could be a login, a step-up, or the account recovery. But with that, we're essentially solving the problem of having users adopt a biometric capability quickly and efficiently. Now I'd like to showcase a use case around step-up authentication. So these are actions like sending high-value transfers, withdrawal events, changing of address information, other sensitive information, where in most cases, a bank may stop the transfer from happening if it seems to be suspicious or fraudulent. What you should do in practice is that you can assure the user's identity with a simple look in the camera and continuously verify their identity in less than a second to make sure it's the genuine account holder making this transfer. So in this example, you see a user making a bank transfer above a limit of $100, of $120 to a recipient in the Netherlands. And we're going to authenticate this payment with a simple look in the camera, without a need for copy-pasting an SMS OTP code, without the need for a second token application, which is very used in the German-speaking countries, so Germany, Austria, Switzerland, where each and every bank has an actual second application whose sole purpose is to authenticate payments, meaning the user has to authenticate into that app, so unlock that application, copy a PIN code or click on a tick mark, and then hop back to the main banking application for that transfer to be secured. The other use case I want to touch upon is account recovery. That is obviously the major challenge that we're hearing, even with user populations who've adopted Passkeys for a seamless and passwordless login. Imagine you've lost your device and you want to log into your bank account. You typically call the call center and you answer security questions. You may physically show up in a branch or go to an ATM machine to basically prove that you are the person who owns the account by presenting your card into the machine. Or you have to redo the whole digital onboarding process and go through another IDV or KYC process from the get-go. With keyless, what we're able to do is associate the user's information presented into the camera with the biometric data that we stored server-side, without the data being stored being considered biometric information, and recover the user's account. So the user in this example clicked on Recover My PIN. They presented their unique identifier. In this case, it was the fiscal code. This could be an email address or any of that. That bank hardened the flow with an SMS OTP, which is fully optional. And the user simply presented their face into the camera, and it was matched against the biometric profile that was stored server-side, and the user was allowed to recreate the PIN code and log into the application. So with a simple look in the camera, in a process that takes less than a second, we're able to verify the user's identity and make sure it was the genuine account holder who initially onboarded to the account from a device that wasn't used before. So we've looked at the existing modalities of local biometrics and centralized biometrics. We looked at that new nascent category of decentralized biometrics and our implementation of a zero-knowledge biometric authentication paradigm that offers a complementary capability to Passkeys, protecting not only login events, but continuously verifying users' identity across the authentication lifecycle, especially for step-up actions and account recovery, where we're able to increase operational efficiency, reduce call center volumes, and protect from account takeover fraud coming through those recovery use cases. So with that, I'm thanking you for your attention. Very happy to take any questions that you may have. Thank you. Please.
And
Hey, hi, thank you for the nice presentation. My name is Valmik, and maybe I missed some parts, but what I'm curious to know is you mentioned cryptographic device verification. I'm interested in knowing how do you do that without WebAuthn 2.0, which is Passkeys basically. I know that we could do that with WebAuthn 1.0, but I'm curious to know how do you do cryptographic device verification without Passkeys? Thank you.
Thank you. So it's not device fingerprinting in the traditional sense, but we're generating a cryptographic key pair that is stored on the user's device that is then authenticated via zero-knowledge proof. So we can cryptographically assure that it is one of the devices the user linked to their account, but we don't know anything about the device itself.
So are you using like subtle crypto API or something? Like what are you using? That's what I'm more interested in knowing. Like what are you using for that key pair on the device itself? I know that you'll store it somewhere later on and use it for verification, but for creation on the device itself, what are you using? I'm more interested in that.
No, so the biometric matching doesn't happen on the device. That happens on the server side. And the device key pair is different from the ultimate key that is reconstructed upon positive authentication. But it's a device key pair that is then cryptographically verified through a zero-knowledge proof as part of a subsequent authentication. So we require the user's device distinct from the user's face to then reconstruct the ultimate signing key as part of a positive authentication.
Thank you.
okay, other question?
Yeah, so thank you for the presentation. Quick question, you said when you do the new user registration, you capture the face print, and then when they authenticate, you're using that face print to continue, right? So there's no biometric enrollment. But now my problem is, if you do it this way, And even in the recovery, you are just using the facial footprint, right? To say, I see who you are, I trust you as a customer, I'm going to let you in.
Mhm.
The problem is, how does this all work? Like, how does this all tie back together? Because if you're on the web and not on the mobile, because all the use cases that you showed was all on the mobile device, but not on the web channel. So how do you take care of all of this in the web? Can you still use the webcam on the cameras, on the MacBooks and the laptops and the Windows and all of that stuff, or this is only limited to the mobile apps?
Yeah. No, thank you for pointing this out. And indeed, this presentation was focused on a mobile SDK that is embedded in a consumer-facing application. What we also have is a web SDK that runs in browser, which is slightly different. In that modality, we don't bind the device to the account because obviously you're running in the browser. It's completely device agnostic and happens in the web. For that, we are complementing the facial biometric with a passkey for device verification as an optionality. But in that modality, we're basically performing liveness and face matching as a one-factor biometric factor, just looking into the camera of any device. But that is agnostic to the operating system, the device itself. It just has to have 720 pixel resolution or higher.
So on an average, if someone adopts this, what is the cost difference between the legacy way of doing this and adopting the zero trust? Like, what is the cost per user? Like, again, not too granular. Is it more expensive as compared to the other one?
No, it depends on the user base. So it's not transaction based on the number of users. Compared to existing solutions, it's a lot, I wouldn't say a lot cheaper, but compared to IDV products is a lot cheaper, and it's different, it's not transaction based. But the business outcome that we're delivering, or the return on investment, is significantly higher than the investment into keyless. But that depends on the user base. But it's in the sense.
Right. Any more questions? Okay. All right. Thank you, Fabian.
Thank you very much.